frequencies in the normal electromagnetic spectrum have different applications. Would the same be true with scalar waves?
Yes, indeed. Such fantastic applications, it's very difficult to describe in a few words. For example, if you understand a Fourier transform, a Fourier expansion, you can represent any kind of a shape, a reasonable shape, or by a Fourier expansion. And by two Fourier expansions, like the interferometer business, you can represent a three-dimensional shape. So you can actually build a wave that will actually go inside, and if you want to resonate with one particular kind of molecule or one particular kind of atom, you can pick the complex of frequencies that we know about or that are connected with one kind of atom, for example. And you can go in and you can hit that atom. You can reach down into the nucleus, because the scalar wave will go through the Faraday cage of the orbital electrons, go right on down into the nucleus. You can enter the strong force reactions that binds the nucleus together, and you can actually transmute the element into something else. Kervran was nominated for the Nobel Prize in '77. He didn't get the prize, but he was a nominee for proving that living systems can transmute elements. And in fact, that's the way they do it. With the scalar interferometer they've got in their head, chickens, human beings, oat, wheat, barley, and everything which has comparable structures can actually transmute one element into another in a small fashion. And so you can do innumerable things. You can match almost any pattern and almost any shape and almost any interaction. You can bias the quantum level statistics. Instead of the quantum level being absolutely statistical, you can bias the statistics and change the probabilities in one way or the other. And so you can cause, any change that you can get by changing the collapse of the state vector and having different probabilities than what you started with. And that's an enormous application alone, just by being able to do that with these scalar waves.
Is all of this information presented in the material that you've got published with the Tesla book?
Well, I'm putting it out as fast as I can. Not all of this is in there, but the gist of all of it is in there. And some of the mechanisms, for example, are in that Part 4 paper. Mm-hmm. I'm working on a paper now for the weather engineering. I have a rough outline, with some filled in, for the applications of a scalar theory of medicine, by means of which you should be able to do some rather enormous things in medicine. And it turns out that some of the older guys who were suppressed like Tesla did those things using scalar waves.
Mm-hmm. One last question here. It seems to me this would also be very useful in the field of communications.
Indeed, because you can make waves that go slower than the speed of light, or you can make them that go faster than the speed of light. You can make waves that go through the ocean.
Mm-hmm. This is really kind of an endless vista here that you're opening up.
Well, that's what this show is all about, Craig.
Mm-hmm. Okay, well, I know you're about out of time, so
all right, Craig. Thank you very much for your call and getting
nice talking to you, Craig.
Sure.
On the line. We have time, mate.
He included a document that he claims was signed between the United States and Russia about 1970, and it was an agreement between the United States and Russia not to use weather-influencing machines as offensive weapons. I wondered if you had heard anything about that.
I know there is some kind of agreement between the Soviet Union and the U.S. in the field of weather engineering, but I don't know the gist of that agreement.
Well, we know what the history of an agreement with the Soviet Union is. It means nothing.
Okay, well, thank you very much.
Okay, David, thank you. Tom, thank you very much for staying up late and electrifying us again with the Tom Bearden world.
Thank you, Bill. It's a real pleasure.
All right, Tom. We'll be checking with you later. Thank you so much for joining us. We'll see you next week.